A combination is the number of ways to choose R objects from a group of N objects without regard to order, which is in contrast with permutations because where the order matters. So if we're looking for permutations of 3 items, the arrangement ABC is different from CBA. However, with a combination, the arrangement of ABC equates to the arrangement CBA, so those are not considered different combinations. And as I said, think of the combination lock. It really should be called a permutation lock because the order that you put the numbers in makes a difference. And here's the formula for the combination. It's very similar to the permutation, except that now we're multiplying the number of objects selected, factorial, times the total number of objects minus the number of objects selected, factorial, in the denominator. And we can see that here is the permutation formula, and here is the combination formula. This is just a quick review of the permutation and combination formulas. You'll notice they're similar. And again, the main difference is that with a permutation, the order matters. So generally speaking, you're going to have more arrangements with a permutation than with a combination. And here's a simple example, again using the 3 books, A, B, and C. And I want to know how many combinations of 2 books that I can place on the shelf, irrespective of order. Now we have AB, AC, and BC. We don't include BA, CA, or CB because in a combination that order doesn't matter, and so those combination of AB is the same as BA as far as the combination is concerned. And you'll see we have fewer outcomes than when we had the permutation where the order matters. Here's an example. There are 12 players on a basketball team. The coach must pick 5 players among them for the starting lineup. How many possible outcomes are there? Well, in this case, does it really matter if they pick player A first, B first, C first, D first, or E first? No, so the order does not matter, and we would go ahead and pick combination. And we would calculate the formula with the combination. Here there are 12 players on a basketball team. The coach must pick 5 players among them for the starting lineup by position. How many different outcomes are possible? Well, in this case, the order does matter because we're going to do a starting lineup by position. In this case, we would pick the permutation. And just by looking at the formulas, you can see that we've added the R factorial into the calculation. So the R is the number of objects selected, and we're multiplying that times the denominator that's in the permutation formula. So when we increase the denominator, we're going to have a smaller outcome or a smaller result in our fraction. Here are the combinations of the explanation of the combination that we were just talking about and how it plays out in the appropriate formula. And again, in this example, in the first example here, the combination example, we're just picking 5 players from 12. And in the second example, we're picking 5 players, but we're also, ranking the players in the starting lineup according to their ability.